Sarah, have you ever thought about time travel? Time, the ceaseless tick-tock that governs our lives, is an enigma that has fascinated humans for centuries. Yet it's not as straightforward as the relentless march of seconds, minutes, and hours. It's a complex concept, a dimension like the three of space we are familiar with, but with its own unique characteristics. Let's delve a bit into the realm of physics. It was Albert Einstein, with his groundbreaking theory of relativity, who proposed that time is not an absolute entity, but rather a relative one. What does this mean? It suggests that time can be influenced by gravity and motion. A clock at the top of a mountain, for instance, will tick slightly faster than one at sea level. This is known as gravitational time dilation, a concept that has been experimentally verified. But let's take it a step further. What if we could travel at near light speeds? According to Einstein's special relativity, time would slow down for us relative to someone who is stationary. This is known as time dilation due to relative velocity. To illustrate this, let's imagine a tale of two twins. One remains on Earth, while the other embarks on a journey through space, traveling at a velocity close to the speed of light. When the traveling twin returns, they would find that they are younger than their Earth-bound sibling. This is not a fanciful tale or a plot from a science fiction novel. It is a consequence of the laws of physics as we understand them. So, in a sense, we've been discussing time travel all along. The traveling twin has, after all, journeyed into Earth's future. When the traveling twin returns, they would be younger than the twin on Earth due to time dilation. It's a form of time travel into the future. But what about traveling to the past? Now that's where the complexities of time travel really start to unravel. Theoretical physics does entertain some concepts, such as wormholes and closed time-like curves, which in theory could lead us back in time. Imagine, if you will, a wormhole, a bridge or shortcut through the fabric of space-time. This tunnel, if traversable, could potentially connect two distant points in space or even 2 points in time. Yes, you heard it right, a tunnel through time. Then there are closed time-like curves. These are loops in space-time that could theoretically allow objects to return to their own past. However, these concepts, while fascinating, are purely theoretical and haven't been observed in our universe. But let's assume for a moment that we could travel back in time. There's a snag, and it's called the grandfather paradox. Here's how it goes. If you could travel back in time and somehow prevent your own grandparents from meeting, you would never be born. But if you were never born, how could you have traveled back in time to prevent them from meeting? It's a paradox, a loop that cannot be resolved. This is where the concept of causality comes into play. Causality is the principle that everything in our universe has a cause and an effect. The effect, you traveling back in time, cannot happen before the cause, you being born. If it did, it would violate the law of causality and throw the logic of our universe out the window. So, does this mean traveling to the past is impossible? Not necessarily. Some physicists suggest the paradox could be resolved through the concept of multiple timelines or parallel universes. But that's a topic for another time. In conclusion, time travel, especially to the past, is a fascinating concept riddled with paradoxes and complexities. It's a conundrum that challenges the very fabric of reality. But isn't that what makes it so intriguing? After all, where would we be without a good time travel paradox to keep us guessing? Some physicists suggest that time travel to the past might create alternate timelines, where your actions have consequences in a parallel universe, not our own. Let's take a moment to ponder this. Imagine we have the power to travel back in time. We could potentially alter the course of history, but whose history would that be? Ours? Or that of another parallel universe? An alternate timeline that was spun into existence the moment we ventured into the past. This is where the concept of multiple timelines comes into play. Now, it's important to note that this is purely theoretical, but it's a concept that helps us grapple with the paradoxes that time travel presents. Think of timelines as a vast array of threads, each representing a different version of reality. Every decision we make, every action we take, could spawn an entirely new thread, creating a new timeline where that decision or action has its own unique set of consequences. Now, if we were to travel back in time and change something significant, we wouldn't actually be altering our own past. Instead, we'd be creating a new timeline where that change took place, a fresh thread in this vast tapestry of reality. So, if we were to, say, prevent our grandparents from meeting, We wouldn't vanish from existence. Instead, we'd simply create a new timeline where we were never born. Meanwhile, our original timeline, the one where we were born, grew up, and eventually traveled back in time, would continue to exist, unaltered. But what about the other version of us? The one in the new timeline? Would they have our memories, our personality? Or would they be an entirely different person, shaped by an entirely different set of experiences? And what about the countless other timelines that could potentially exist? Could we ever hope to explore them? Or are they forever beyond our reach, separated from our own reality by an insurmountable barrier of time and space? These are the questions that the concept of multiple timelines forces us to consider. It's a notion that challenges our understanding of reality and forces us to rethink our place in the universe. But let's not forget, this is just one interpretation of the complex and often confounding concept of time travel. It's a fascinating possibility, but it's also a topic of ongoing debate in the scientific community. Some physicists argue that multiple timelines are nothing more than a mathematical abstraction, a theoretical construct with no basis in reality. Others, however, maintain that they could be real, a hidden aspect of our universe that we are yet to uncover. In the end, whether multiple timelines exist or not, the very idea of them expands our understanding of the universe and the myriad possibilities it holds. It encourages us to question, to explore, and to dream of what might be. It's one interpretation, and it's a topic of ongoing debate in the scientific community. Well, even if time travel remains theoretical, it's incredible to think about the possibilities. The wonders of science lie in its boundless potential, its ability to take a seemingly ordinary concept like time and unravel layers of complexity that challenge our understanding of reality. Time travel, while still a topic of speculation and debate, serves as a testament to the human spirit's relentless quest for knowledge. It's a concept that challenges our understanding of the universe and pushes us to question, explore, and dream. The beauty of science is not just in its discoveries, but in the journey of seeking answers. It's about embracing the unknown, the what-ifs, the could it be possible. It's about venturing into uncharted territories of thought and possibility. We look at time, not just as a linear progression of moments, but as a fascinating dimension that could potentially be manipulated and traversed. The idea of time travel highlights the dynamic nature of scientific exploration. We don't shy away from the paradoxes or the conundrums. Instead, we lean into them, using them as fuel to drive our curiosity further. The grandfather paradox, the concept of multiple timelines, these are not roadblocks, but intriguing puzzles that beg to be solved. And while we may not have a working time machine or a definitive answer to whether we can indeed travel to the past, these are not failures. They are stepping stones in our continuous journey of understanding the universe and our place in it. Every question we ask, every theory we propose, brings us one step closer to unraveling the mysteries of time. The beauty of science also lies in its ability to inspire, to make us look up at the stars and wonder, to make us question our understanding of reality, to make us dream of the seemingly impossible. Time travel, in all its complexity and mystery, does just that. It encourages us to dream, to imagine a world where the boundaries of time are not as rigid as we once thought. And that's just it. The boundaries of possibility are not set in stone. They are not defined by what we currently know or understand. They are constantly shifting, expanding with every new discovery, every new theory, every question we dare to ask. Science is not just about finding answers, it's about asking the right questions. It's about looking at the world around us, the universe beyond us, and daring to ask, what if? It's about exploring the seemingly impossible and pushing the boundaries of what we believe is possible. That's the beauty of science, Sarah. It keeps us dreaming, exploring, and questioning the boundaries of what's possible.